Okay, so we continue the lesson. So let me just remind you what we talked about logarithms before. So I would say that if let me write it in this form this time. If a is positive and if a is not equal to 1, if a is not equal to 1, and if x is also a positive number, then under these conditions I can talk about logarithm of this number, for example, in base a. Yes? So whenever you see this symbol, you need to remember that a, this number which is called the base, should be positive, not equal to 1. The number sitting in front of the log should be a positive real number. And I just told you that in your book, this is the first time that I see, they put this a on top here. They write it like this. So if you see this in the book, it means what I have written here. Okay, and then I told you that there is a convention. If this a is 10, we don't write it. Yes, we just simply write log of x, meaning that this is just log of x in base 10. Because base 10 is more popular, so we just get rid of writing it, so for simplicity. Okay. And then let me ask you, what is the meaning of this? When you see log of x in base a, this is essentially asking you, can you give me a number so that when I raise a to the power of that number, it becomes x? Yes? So whenever, for example, if I ask you what is the logarithm of 4 in base 2, so let me write 8 in base 2. So this is essentially asking you, can you give me a number here so that when I raise to that 2 to that power, it becomes 8. So in this case, it is simple and the answer is 3. But if I ask you the same question, log of 9 in base 2, this is asking the same question, can you give me a number so that when I raise 2 to that number, it becomes 9? There is a number, and there is exactly one number with that property, but that is not a number that I can calculate on top of my head. So I can use the calculator, and of course the question is that how calculator knows to calculate that number, because that it has been programmed by more advanced mathematics. So for the time being, you don't need to bother about that. But what we know is that this number is definitely larger than 3 and smaller than 4. So for the time being, the only thing that we can say about the value is that it's something bigger than 3, less than 4. Yes? But what value, we don't know exactly. So in principle, if someone tells you that the log of x in base a is a number b, what can you conclude? You can conclude from here that when I raise a to power b, the answer becomes x. And importantly, this is double-sided. Sometimes you have to translate the log expression into exponential expression. Sometimes you should also know that when you have the exponential expression, how go back and write it in logarithmic form. Yes? So this is the only thing that you need to know in the definition of the logarithm. Yes. And then we started solving some problems. Some problems was easy to guess, and then I gave you some examples which were not easy to guess, and then we learned how to calculate them. Yes. For example, to fresh up your memory, so let me just ask you, for example, what is the answer to this logarithm? So 1 over 27, and I write the base to be 3. So it is asking you, can you give me a number here so that when I raise 3 to that power, it becomes 1 over 27. Yes, Sergey? It's minus 3, yes? Why is that? Because 3 to the power of minus 3 is 1 over 3 to the power of positive 3, but this means 3 times 3 times 3, and then everyone knows that it is just 1 over 27. If you can guess, this is the way that you do it. If you cannot guess, what do? You write it as an unknown. You say that, okay, what is this? So you call it x. Then you would think, this will tell you that this number to this power is equal to this number. But then hopefully you need to know that 27 is 3 to the power of 3. And then you bring it up, it becomes 3 to the power of minus 3. What is the purpose of doing all these gymnastics? Is because we want to have something like this. 3 to the power of x turns out to be equal to 3 to the power of minus 3. If you compare these two, on the one hand they are equal, on the other hand this number is exactly equal to this number. So then the conclusion is the top one should also be equal to the top one, otherwise the equality does not hold. And this tells you that the x that you were looking for is minus 3. For the simple cases, you might be able to guess, but for the hard cases that we had some examples before, guessing is not probably a good option. It's better to do the calculation. Yes? For example, let me give you another example. So what is your opinion about this? You can mix a guesswork with calculation, of course. For example, let me just ask you this question. Logarithm of logarithm in base 16. Now this is 16, base 2, base 4, base 8. Okay, so first of all, let us understand what does it mean. I hope that you understand what it means. It is not a product. Yes? This means that you have 16, you calculate the log of 16 in base 2, the whole package becomes a number. Whatever this number is, you calculate the log of this number in base 4. Again, it becomes a number. Whatever this number is, you calculate the log of this number in base 8. It's exactly, for example, you have x to the power of 2 to the power of 3 to the power of 5. Yes? So you raise it to power 2, whatever it is, you raise it to power 3, whatever it is, you raise it to power 5. So this is consecutive powers, but this is consecutive logarithms. Yes? But that should be also easy. But by the way, this is a standard in mathematics. We do not put these brackets. For the time being, I want to put them so that you are not confused. But the way that I wrote it in the beginning was the standard way of writing it. Because if I ask, can I ask you what is log of 8? How much is log of 8? Can I ask this question, or this is nonsense? It's nonsense, yes? Because I have to give you a number here. So this is why there is no matter of confusion. If I write log of 16 in base 2, and I just simply write log of 4, there is no matter of confusion. This means this is the number sitting in front, yes? Because log of 4 in itself is meaningless unless there is something in front of it. And then it becomes clear this is something in front of it. Okay, so what is the answer? We can calculate it in our head. So you have to calculate this. This is simple. What is the answer? 4. This is 4. Now you have 4. So if you want to, you can write this very properly. So I copy and paste the first part, copy and paste the second part. But instead of this, I can write what? 4. And then I continue one step more. Now I have to calculate log of 4 in the same base 4. What's the answer?
1.
1. Exactly. So then it becomes log of 1 in base 8. Then what's the answer? Yes? 0. Because 8 to power 0 is 1. So this expression is exactly 0. Yes? Let me give you one more and then we go to the new lesson. So for example, what is your opinion about this? Log of second root of the third root of 10. Again, remember the convention. If the bases are not written, automatically they have to be considered to be 10. Okay, so I can wait a little bit for you. So what is the simplest possible case that we got? Do you have any answers yet?
Log of 1 over 6.
Yes, that's it. We cannot go further than that, yes? Yeah, so what you can write, first of all, you need to understand what is the meaning of this combination. So how can you understand this? So this is the square root of this number, but this number has an exponential form. What is that? It's 10 to the power of what? 1/3. Yes? But then this can be written as 10 to the power of 1/3 to the power of 1 over 2. Agree? Because I am using this rule. I told you that memorize them once for all. So the nth root of a is a to the power of 1 over n, meaning that the second root of a is a to the power of 1/2. So every third sign can be written as an exponential function in which the power is a fraction. Yes? So what I did, I copied and pasted the first part. I didn't touch this first third sign, but instead of this expression, I used this formula for n equals to 3 and I wrote it like this. And now I give the role of capital A to this guy. And then I have the second root of capital A, which I can write the capital A to the power of 1/2. But capital A is this guy, so this one to power 1/2. But we already know how to deal with powers, yes? I have an exponent, raise it to another exponent. So what is the rule? It's just from very elementary mathematics, so we have to multiply the exponents. So then it becomes 10 to the power of 1 over 6. Yes? Okay, so that is, the question mark now becomes log of another log, but instead of that expression, now I am allowed to put 10 to the power of 1 over 6. That's also good. So what is the answer to this part?
1 over 6.
1 over 6. Why? Because I told you that when you write log of 100, you answer 2. Why? Because you are asking 10 to which power becomes 100. Now I am asking you this question. 10 to the power of 1/6. This is asking you 10 to which power becomes this number. Yes? So this question mark is 1 over 6. You really don't need to do it. Everyone understands that. So this means that the whole package here is just 1 over 6. So this becomes log of 1 over 6. And then I cannot go further. Because if I want to go further, it means that I should be able to answer this question on top of my head. 10 to which power is 1 over 6? But there is no nice connection between powers of 10 and 1 over 6, so I have to stop here. It doesn't mean that this is nonsense. No, it is meaningful because 1 over 6 is positive. But then if you calculate, you have to calculate it using more advanced mathematics or using your calculator. And the reason that I was, this is actually good to learn that, but if I have given you this question, this question is nicer. Okay, now can you calculate this one? This turns out to be a nice number at the end.
It's 1.
No, just be careful. Okay, let everyone do it. Okay. Okay, do you have the answer?
-1.
Yes? -1. Thank you. So it's -1. How? Again, if you want, we can do the 5th root of the second root of 10 here. And then this becomes the 5th root. The second root can be written as 10 to the power of 1/2. Now 10 to the power of 1/2 again to the power of 1/5. So this becomes 10 to the power of 1 over 2 times 1 over 5. This becomes 10 to the power of 1 over 10. Yes? So this means that this question mark is equal to 1 log, another log immediately after that. Instead of this, I would write 10 to the power of 1 over 10. This log is asking you, can you give me a number so that when 10 is raised to that number, the answer becomes 10 to the power of 1 over 10. It's very clear. What's the question mark then? 1 over 10. Yes? And then I have a log here. So this becomes log of 1 over 10. Now this is asking you the same question, but for this new number. Can you give me a number so that 10 raised to that number, it becomes 1 over 10? So what's the question mark? Minus 1. That's the answer. Yes? Okay, now let us continue. This lesson is the new lesson now. So properties of logarithms. Yes? Okay, so I want you to memorize that, even though they are given in the formula sheet, all of them, but I really want you to start learning them and sending them to your memory. I will start with very, very simple ones, but I want to ask your opinion about that before. So property number 1. If a is a positive number and a not equal to 1, under these conditions, if I ask you log of number 1 in base a, what is your answer? Do you need to know a, or you can immediately answer this question regardless of the specific value for a?
It's 0.
It's 0. Yes? So you really don't need to bother. So somehow people use this sloppy language and say that log of 1 is 0. But they mean log of a in an acceptable base is 0. Yes? Is that clear? Because this is the only number, so that a raised to that number, it becomes 1. So log of 1 is 0. But now another one is log of a number in its own base. What is this one? Any number, the log of this number in its own base. Yes.
1.
Yes, that's 1. Yes, so because a to power 1 is equal to a. So they're a very simple property, even though they are also given, but I want you to understand them. But one very important result is this. Actually, that is not a result. That is, it seems to be writing the definition of logarithm in a different way. So, if a is positive, and if a is not equal to 1, and b is positive, under these conditions, if I ask you what is a to power of log of b in base a. So you need to remember this structure. This number, this base and this base are the same numbers. But the whole logarithm is playing the role of the exponent. If I want to exaggerate writing so that it becomes clear, so you have a to the power of logarithm of b in base a, something like that.
Yeah.
So you are raising a to a logarithm so that the base of that logarithm is this number. So what will be the answer?
B.
It becomes b. Why is that?
Because log of b with base a is the number which, when you raise a with it, it becomes b.
Yeah, and that's exactly the same thing. So that's just very, very simple. You see, what is, if I ask you what is log of a in, what is log of b in base a? You will tell me this is the number so that when I raise a to that number, it becomes b. Now I am raising it to that number. So the answer should be b. So that's just the definition of logarithm, yes? So logarithm of logarithm of b in base a is the number so that when a is raised to that power, yes, the answer becomes a. Yeah, is that understandable or not? That was exactly what I mean by logarithm.
Yes.
Logarithm is the number so that when a is raised to that power, the answer becomes a. Now what I am doing, I am raising a to that power. So what's the answer then?
B.
B. Yes, that's just exactly the definition of B. So for example, I say what is the square root of 7? You say a square root of 7 is a number so that when I raise it to power 2, it becomes 7. Now I am raising it to power 2. The answer becomes 7. It's more or less the same kind of argument. Yes?
Doesn't it become B?
Yes.
Yes, thank you, sorry. Thank you. Yes, sorry. Okay, so that is an extremely important property. Actually not property. Don't say it's a property. It's just the definition of the logarithm. But written in a nicer way. So, before going any further, let me just give you some examples. For example, if I tell you what is log of 1, what's the answer? Yeah? It's 0. Because it is log of 1 in base 10. But I told you that in any acceptable base, the log of 1 is 0. So the log of 1 is 0. So if I ask you what is the log of 1 in this base? What is the log of 1 in this particular base? Again, 0. So doesn't matter. If I ask you what is the log of 10,
1.
what's the answer?
1.
It's 1. Because this is 10, and by convention it is not written, it is 10, A in A, you know? A in A, the answer is 1. So log of 10 is 1. So what is log of square root of 5 in the base square root of 5? 1. So it doesn't matter how these numbers are complicated. But let me, for example, ask you this. If I write 2 to the power of log of 8 in base 2, what's the answer?
8.
It's 8. But for this problem, if you don't understand that, you can still solve the problem. How? You can say that, okay, 2 to the power of log of 8 in base 2 is equal to 2, I copy and paste, but instead of this, I can immediately understand what the answer is. What the answer is?
3.
Log of 8 in base 2 is 3. So instead of this, I can simply write 3. But 2 to the power of 3 is what? 8. So for this one, I have two alternatives. Either solve it in that way, or solve it using the definition. But if I change this 8 to 7, then 2 to the power of log of 7 in base 2, only this method will work if you are interested in the exact value. Because if you want to follow this method, even if you have your calculator will give you some approximate values here. And this is not exactly the number that you want. But if I ask you what is the answer, what is the answer? 7. Not because of this. The meaning is this. But we cannot do this in this way. We have to use the formula. Yes or no? Okay, let me test your understanding now. If I ask you this question, so let me put a 2 here, and then write log 7, 2. What is the answer? What is the exact value? Of course, if you have calculator, you can put these numbers. By the way, learn how to do this. In calculators, you do not have access to log in any kind of base you want. There are two buttons on the calculator. One of them is just log. It means that this is the standard log with base 10. And you have another one which is called ln. We will learn about that in Math 3C. So this, you have this button on the calculator and this button on the calculator. But I will teach you, if you want to calculate this using your calculator, what to do. Okay, but we have to wait to find new rules for logarithms. Yes? So for the time being, forget about the calculator, but try to understand the problem. Without calculator, you can calculate this exactly.
28.
No.
No.
It's not 28, yes?
49.
49. Can you defend that? So how?
So the method I did, it might not be the correct, but we know that I got this rule from the scientific notation, so we can split that number up into 2 to the log of 7 over 2 times the same number. and that we can simplify into
Exactly,
7
exactly.
times 7.
Okay, but if you have this 10, what do you want to do? Write it 10 times? If essentially that method will work, but I'm just giving you the hint. Don't do that. If this is 100, you want to write it 100 times. So what is the trick? If this number is so big that you are not patient to write all of them, what should we do? So you need to use this. It's important to know the rules of powers crystal clear in your head. So this is mn. Yes? So what you need to do, yes?
Well, I thought you can split up the number into 2 to the power of 2 and multiply by 2 to the power of log 7, 2.
And more or less that was what Simon mentioned. But if I have more than 2, then you have to do this many times, yes?
Yeah, so you split it up into 2 to the power of log 7.
Yes, log 7 in base 2,
Yeah,
and then the whole expression
to the power of
to
2.
power 2. Why is that? Because give the role of m to this, give the role of n to this. 2 to the power of m to the power of n. What will happen? It becomes 2 to the power of m times n. So this 2 times logarithm of 7 in base 2, hopefully you understand that can be written in this form, yes? Is that understandable for you? Yes?
What if we don't write the parentheses or bracket?
No, that is wrong.
That is.
I will tell you. No, not that is wrong, but that is not this expression.
Yeah, I know, but how?
No, there is no way for doing that.
Okay.
So if you write it, first of all, this cannot be written in that form. But if you're asking about this question, something like this. First of all, if you write like this, people read 7 to power 2. So if you mean the whole expression, you have to write it like this. But then there is no way to calculate. You have to calculate this, and then whatever you get, you have to raise it to this power 2. Whatever you get, you have to raise 2 to that power. But anyway, here, what happens, the answer to this part you know. What is the answer to this part?
7.
Is 7. So you write 7, but you have a 2 on top. And then it becomes what?
49.
49. So for example, now if I ask you this question, if I ask you, in principle you can solve it, but of course, if I ask you 3 to the power of 100 times log of, I don't know, 5 in base 3, what's the answer? You can get rid of logarithm here by the same trick that I told you. Because what do you write?
5 to the power of 100.
So you write it as 3 to the power of log of 5 in base 3, and the whole expression to power 100. But the answer to this is, what is the answer to this part? 5. So it becomes 5 to the power of 100. But I cannot go further. The answer is 5 to the power of 100. Yes? Is that clear?
Yes.
Okay. Let me ask you another question. What do you think about this scenario? 2, or let me write, for example, 5 to the log of 3 base 5, and then plus log of 4 base 5. So this is a number, that's a number, I add them, it becomes a number, I raise 5 to that power.
12.
Is that understandable? It is 12. Why? Because there is another rule. If I have a to power m plus n, I can break it into a to power m times a to power n. Yes? So I have 5 to the sum of two numbers, so it can be written as 5 to the first one times 5 to the second one. First tell me, is that understandable or not? I'm using that rule. So it is important to really master those rules. Yes? And then I told you, what is the answer to this part? It's just a matter of seconds. What is that?
3.
3. And what is the next one?
4.
4. So the answer is just simply 12. Yes? What happens if I subtract them instead of adding them? And so what happens if I have 5 to the log of 3 in base 5 minus log of 4 in base 5?
It's minus.
Yeah, just what is it?
3 over 4.
3 over 4. Because now this time you can write 5 to the power of log of 3 in base 5 divided by 5 to the power of log of 4 in base 5. Why? Because if I have a to the power of m minus n, I can write it as a to power m divided by a to power n. Yes? And then what happens? No one has problems, hopefully, with the numerator. It's a standard 3. This is also a standard 3 over 4. That's, this answer is very simple. It's 3 over 4. So what happens if I want to do this? I don't know. 3 to the power of 4 log of 2 in base 3 plus, I don't know, log of 5 in base 3 minus 3 log of 2 in base 3. What's the answer?
I know the answer. Oh, yeah.
4, 3.
The answer. I can say that.
I don't know the answer myself, but you can say it, yes.
40.
40?
Yeah.
You also got 40. So probably
Yeah.
2, 1. So 40, let us check 40 later.
Correctly. 3 over.
Okay, but I want to be pedagogic, so I will explain everything again. So the question mark is equal to. Okay, what is the first step? The first step is this expression plus that expression minus that expression. So what can I write? I can write 3 to the power of 4 log of 2 in base 3 multiplied by 3 to the power of log of 5 in base 3, but because this one is minus, I have to divide 3 to the power of 3 log of 2 in base 3. So, first of all, tell me, is that understandable what I have written? I am claiming that this question mark is equal to that. Everyone agrees with that or not? Yes?
I mean, since you have 4 logarithm of 2 base 3.
That is better, I was careless.
Yes, so it's 10.
Yeah. So no, I mean, here, or you are here, it's not a good question that I made, because 4, by the way, so that I was careless. I don't know, might be you calculated better than me. 4 log of 2 in base 3, I have minus 3 log of 2 in base 3. So what can I write?
Yeah, so it's just.
I have 4 of them, 3 of the same thing is gone. So what is left? 1. So that's not a good question, okay? So if you don't mind, let me change this one and make it, for example,
I know I didn't make a mistake.
4. Let me make it 4. Okay, so then what happens? This becomes 4. But again, let me wait for you. Do you understand what is going on? In the previous case, that was not wrong. It was simple than I was thinking. Because in that case, you can combine these two and make it simple. But the way that I have written it right now, it is not possible to combine them. Yes? And now we write it in that 4. First tell me, is that understandable why suddenly this jumped into the denominator, yes? Because it appears with a negative sign. But this appears with a positive sign. So they are multiplied, but the third one is divided, yes? So then, what can I do with this one? Then I have the problem that I already know. I know what to do with this kind of combinations, yes? I would write it like this, and then I raise it to which power? 4. And then this I don't need to do anything. By the way, what's the answer?
5.
5. In the denominator, I can do the same trick and then raise it to power 3. And then one more step probably will finish the problem. What's the answer here? It's 4. But I have a 4 here, 4 to the 4 times 5, and then divided. This is 4 to the power of 3.
Wait.
But I...
Wait, the one up top's supposed to be
2.
Ja,
a 2.
What?
It's supposed
No.
to be.
Here you mean?
Yeah, yeah.
Yes.
Okay, thank you very much.
I think that
Yeah, I thought
So what is the answer then?
6
It's 2.
it's 2.
Yes, thank you. Okay, but you can simplify it, yes? 2 to the power of 4 is 16 times 5. 4 to the power of 3 is 4 times 4, which is 16, times another 4. But this 14, this has 1, so it's 5 over 4.
Ja.
That's what I got.
Alla hade fel.
I don't
Yes.
know 1.25.
Which is the same thing as that.
Yeah, exactly.
Okay,
So you were the only one.
so I hope that at least you learned what to do. So this formula is very good if you see the logarithm in the exponent. Yes? If the logarithm is in the exponent, one of the formulas that you need to think is this one. But if I give you this, there is no way. If I want to calculate 2 to the power of log of 3 in base 5, then I have to use my calculator. And the calculator will not calculate this directly. I will teach you how to use your calculator to calculate this. Using your calculator, you can only calculate log of 3. You can calculate log of 5, but not log of 3 in the base 5. Yes?
My calculator can put any base in.
Oh, that's very good. So that's probably modern calculator. But the calculator that I have when I was younger doesn't have that one. And even if you don't have that one, I will tell you what to do. The reason I want to talk about that is because you will learn something very useful in the language of logarithms. Okay, so that is the second property. Now let us go to the next property, which is very interesting actually. And then sometimes I have seen students get confused, so make sure that you really understand what's going on. And we have to, by the way, we have to finish a little bit earlier because exactly at 4 they have a meeting here. Just let me give you one, let me see my in order. Yes, I am in order. So let me just ask you this question. This property number 3. It's a very nice property. So if x is positive, if y is positive, if a is positive, and if a is not equal to 1, it's extremely important to respect the conditions. So every formula that you study in mathematics has a domain of applicability. You have to respect that, otherwise you get very strange results. It's very interesting that the log in base A, if I multiply these two numbers and get a number and calculate the log of the product in base A, I can do them separately. I can calculate the log of x in base A. I can calculate the log of y in base A. But the interesting thing is that here I am multiplying, but here I have to add. Okay, so that is also some strange property of logarithm. So if you have log of a product, it becomes the sum of logs, not the product of logs. Yes? So, this is the property that we do. And by the way, you don't need to memorize the conditions. Why? Because you see A appears in the base, so it should enjoy the property for a base. X appears in front of a log, so it should be positive. Y appears in front of a log, it should be positive. And if these two numbers are positive, it is guaranteed that the product is also positive. So everything is okay. But now, why do you think this is correct? Why do you think log changes the product changes the multiplication to addition.
Isn't that because of
No, well, let me just prove it, and then we are done. We will talk about the consequences later. The proof is a little bit, probably you need to have experience, extremely simple. But let me just say this. I would say let log of x in A be a number. Let me call it capital M. And let me call log of y in base A is n. But from now on, probably you can help me to solve the problem. So you see, this is a number. For simplicity, I called it capital M. And this is also a number. For simplicity, I called it capital N. But now you should be able to help me to write something in front of this arrow, conclusion arrow. Can you tell me what can I conclude from this? You shouldn't say I don't know. If you don't know, it means that you didn't learn anything.
A to the power of m.
No, which one to power which one?
A to the power
A
of
to
n?
power M should be
X.
X. Okay, so everyone knows that. And then if you tell me that the log of y in base A is n, what can I write in front of this arrow?
A
A to the power
A to the power of n is
Y.
what?
Y.
But now, look here. In the expression that I want to prove, I have x times y involved. So this might motivate us to multiply x by y. Okay? So this means that a to the power of m times a to the power of n is equal to x times y. Yes? But then there is a better way to write this product. There is a rule for exponents. What can I write? I can write one single base, and then what to do what?
M plus n.
M plus n. You see, that is also before, but we didn't respect that much. The product is here, but the sign here is addition. That is the source of this reason, actually. Okay, now, can you tell me how can I translate this into the log language? This I want to learn. This is extremely important. Every power equality. So this, let me write it here on top. A to power of m plus n is equal to xy. This a to some power is equal to this one. This can be translated into the log language. What would be the proper log language here?
Base A and xy.
So you can write what? Log
xy
xy here,
and base A.
base A equals to what?
M plus
M plus n. Do you agree or not?
Yeah,
Because a to power m plus n is xy, and that is telling me the same thing. So this is usually, we don't like it, because usually we go from logarithm to powers, because powers are more, I don't know, we have more knowledge about them. But sometimes we have to go the other way around. This is exponential, we go to logarithmic language. But this is done. Why? Because I repeat the left-hand side, the right-hand side. What is m? M, I introduced it. M is this. And what is n? N is this. So then I do the replacement once more. Instead of m, I put log of x in base A. Instead of n, I put log of y in base A. But what is the operation? Addition. So this means that I was able to show. So it means this is nothing new. This is the same rule in powers that has been written in the language of logarithms. So that is not a new rule in mathematics. The rule, the essential rule is not the logarithmic rule. The essential rule is that I can write this in this form. So that is the same rule expressed in logarithmic language. Yes? Is that clear? So I will not have time to talk about this more, but next time I will start repeating this and then giving you some examples. But that's an extremely important rule. I really want you just right now memorize it. Yes?
If there's no bracket, so it's just log in base A, x times y,
Yeah?
which calculation has to be?
No, this is, you should avoid this. So don't do that. If you write something like this, I would say it's a really sloppy language. Because no one can understand what is going on. If you mean log of x multiplied by y, then it is better to put y here. And if you mean x times y, then logarithm, it is better to put pair of brackets. So you have to avoid that. But if you just punch this in the computer like this, probably computer will interpret it in that way. Yeah, I don't know, but I think that's the impression. So you should avoid this kind of things. Any questions? Okay, have a nice weekend. Thank you.
Have a nice week.